Section 9.1, Part 4, Estimating a Population Proportion. Lesson objectives: construct a confidence interval for a population proportion. Interpret a confidence interval for a population proportion. We'll begin with an example. A USA Today Gallup poll conducted in February 9 through 11, 2007 asked 1,006 adult Americans how much would it bother them to stay in a room on the 13th floor of a hotel. Interestingly, 13% said it would bother them. Construct and interpret a 95% confidence interval. Okay, here's a snapshot of a hotel. If we notice, here's floor 9, 10, 11, 12. There's no 13th floor. And actually, well, there is a 13th floor. It's just called 14th floor. So a lot of hotels do this. So back to the problem. P hat was given in the problem as 13%. So if we express it as a decimal, 0.13. Let's check our assumptions. N times P hat times 1 minus P hat has to be greater than or equal to 10. So we take 1006, multiply it by P hat, times 1 minus P hat, and we get 113.7786, which is greater than or equal to 10. So that requirement satisfied. And the sample size is definitely less than 5% of the population size, because we're talking about all American adults, and our sample size of 1006 is definitely less than 5% of the population size. Alpha is 0.05 because we are doing a 95% confidence interval. So Z alpha over 2 becomes Z 0.025, 2.5%, which we look on table 5 and we see that that value is 1.96. So if we put these values into our formula, we get our point estimate P hat 0.13 minus our margin of error, which is the z-score times the standard error, and we end up with 0.109. For the upper bound, we do the same thing, except this time we take the point estimate, we add the margin of error, and we end up with 0.151. So this is our 95% confidence interval. Now if we interpret this, we would say we are 95% confident that the true population proportion of adults that it would bother them to stay on the 13th floor of a hotel is between 0.11 and 0.151. If we express this as a percent, we would say we are 95% confident that the true population percentage of adults that would bother them to stay on the 13th floor of a hotel is between 11% and 15.1%. Let's look at another example. In the 2009 Parent-Teen Cell Phone Survey conducted by Princeton Survey Research Associates International, 800 randomly selected 16 to 17-year-olds living in the United States were asked whether they have ever used a cell phone to text while driving. Of the 800 teenagers surveyed, 273 indicated that they text while driving. Obtain a 99% confidence interval for the proportion of 16 to 17-year-olds who text while driving. So the solution: P hat is x over n, which in this case x is 273, n is 800, and if we round to 3 decimal places, we get P hat to be 0.341. Check our requirements. N times P hat times 1 minus P hat is 179.8, which is greater than 10. Sample size is less than 5% of the population size. Alpha is now 0.01 because we're doing a 99% confidence interval. So our Z alpha over 2 is 2.575. And again, this can be found at the bottom of table 5. our lower bound is our point estimate minus our margin of error, and again the margin of error is the z-score times the standard error. The upper bound is the point estimate plus the margin of error, and we see that the lower bound is 0.298 and the upper bound is 0.384. Let's interpret this. We are 99% confident that the true population proportion of 16 to 17-year-olds who text while driving is between 0.298 and 0.384. We can also say we are 99% confident that the true population percentage of 16 to 17-year-olds who text while driving is between 29.8% and 38.4%. Now this is our last example. We are given a confidence interval in Minitab. This is coming from the student survey data, and the question is, do you smoke? Our X is going to be how many people indicated yes, they do smoke. So the first thing we're going to do is we're going to identify the point estimate for the population P. Then we're going to find the margin of error, and then we're going to rewrite this confidence interval as a point estimate plus or minus margin of error. Let's begin with finding the point estimate. The point estimate of P is P hat, and P hat is exactly in the middle of the confidence interval. So what we can do is just sort of do an average. We're going to take our upper limit, we're going to add our lower limit, and then we're going to divide it by 2. So P hat is going to be equal to 0.422 divided by 2, which gives us 0.211. This also agrees with what Minitab said. Now there may be a problem where this is not expressed or this, and we can still compute P hat just by using the confidence interval. Let's do the margin of error. The formula for the margin of error is the upper limit minus the lower limit divided by 2. So if we take the upper minus the lower, divide that by 2, we get 0.114 divided by 2, which is 0.057. So our margin of error is 0.057. So to put this in point estimate plus or minus margin of error, we would say 0.211 plus or minus 0.057. Here's the readings and suggested problems. Thanks for watching.